Hi everybody, we're still here. We're in the middle of some factoring review for final exams. So question 29 asks us to factor this binomial. 121 x squared minus 49 y squared. Alright, if you've studied your factoring flowchart, you're going to know that when you have two terms you're trying to factor, first look for a GCF. I'm looking across these two terms and it doesn't appear that they have anything in common. So the next thing I look for with two terms is what we call the difference of squares. That means that both terms are perfect squares, or I could find the square root of both of these terms, and difference means they're being subtracted. So this is what we call the difference of squares. There's really no process here, it's just something you had to have studied and memorized and practiced. When you find the difference of squares, it factors to two binomials that are the square root of this term. So the square root of 121x squared goes here, 11x, and here, 11x, and the square root of the second term, 49y squared, goes here, 7y times 7y, and the signs are one of each, plus and minus. So that's how you factor the difference of squares. You take the square root of each term, it goes in these places, and then one of the signs is plus and the other sign is minus. And it doesn't matter which order you write them in. You could just as correctly write 11x minus 7y times 11x plus 7y. They mean the same thing. It doesn't matter which order you write those signs in. Alright, we're going to solve a quadratic equation. The directions tell us to solve by factoring. So the first step to solving a quadratic equation by factoring is make sure your equation equals 0, and this one already does, so we don't need to do anything to get it there. The second step is to factor the polynomial side. So we're going to factor this whole side of this equation. So we have 12x squared minus 17x plus 6 that we need to factor. And again, I think a few questions back we factored a trinomial like this by using the Colombian method. Since we have a 12 here, we're going to multiply the front and the back, first term and the last term, both by 12. So that gives me 144x squared minus 17x plus 12 times 6 is 72. I'm going to lay out my binomial parentheses. The square root of 144x squared is 12x. So that goes there. 12x times 12x. The first sign comes down. Then we multiply negative times positive makes negative, and we have same signs. So what we're looking for is factors, two numbers that multiply to make 72, but add to make 17. If you know your multiplication facts, this shouldn't be too hard. But we'll make a little list. So we have 1 times 72, 2 times 36, 3 times 24, 4 times 18, 5 doesn't go in, 6 times 12, none of these add up to 17 yet, 7 doesn't go in, 8, there we go, 8 times 9 adds up to 17. So we have 9 and 8 here. And if you're using Colombian method, the last step is to divide by whatever's common. So 12x and 9 have a 3 in common. 12x and negative 8 have a 4 in common. And the 3 times the 4 makes the 12 we started with, so we're good. We're going to divide both these terms by 3. So we have 4x minus 3 times 3x minus 2. And that's just the factoring part, because the next step of solving is to make your little equations. And that has to do with the zero product property. If this binomial times this binomial equals 0, then that means that 4x minus 3 equals 0, or 3x minus 2 equals 0. And then we solve these little equations for x. So add 3 to both sides here gives us 4x equals 3. And then divide by 4 gives us here that x equals 3/4. Let's draw this line down a little further. So add 2 to this, both sides of this equation, We have 3x equals 2, and then divide by 3 to isolate the x, and we get x equals 2/3. And these are both good solutions for this equation. On your final exam, you need to make sure you pay attention to the directions, because a lot of times the directions ask you to only give one of the solutions. So you could choose either one of these to input into iMath AS as the solution for this equation. All right, here we have a word problem. In Tacoma, the tax on a property assessed at $690,000 is $14,490. If tax rates are proportional in this city, how much would the tax be on a property assessed at $750,000? Identify the proportion that solves this problem. All right, so we're writing a proportion, and twice you see that keyword in here, proportion. All right, whenever I write a proportion, I first identify what I'm comparing, and it looks like from this story, we're comparing the amount of tax on a property to the actual property value. So for the first property, it says the tax on a property assessed at $690,000 is $14,490. So the tax is $14,490 for a property value of $690,000. I'm going to compare that to another property. How much would the tax be on a property assessed at $750,000? So I'm looking for amount of tax, so that's where my variable is going to be, and the property is valued at $750,000. So this is the proportion right here. So let's look down here and see if we can find it. Well, we're lucky because I think it's just this first one. This first one matches our proportion. What's wrong with these other ones? If you look at this second one, the wrong value has been assigned to the $14,000, so the tax was not on the $750,000. And here, again, you can write the proportion like this if you want to put the values both on the same side, but the property values have to match the tax values, so the $14,000 on this one would have to go on the top because it matched the $690. So our answer is definitely the A. At the beginning of a basketball season, the Panthers won 40 games out of 90 games. At this rate, how many games will they win in a normal 100-game season? You might not recognize this as a proportion, but it really is, and the key words, again, are at this rate. So we're going to compare things. What are we comparing? We're comparing the amount of games won to how many games were played. At the beginning of the season, the Panthers won 40 games out of the 90 that they played. At this rate, how many games will they win? So we don't know how many they're going to win, but we do know in a normal 100-game season they're going to play 100 games. All right, now how do we solve? In a proportion, you solve by setting the cross products equal, and it makes an equation. So if I set 90 times x equal to 40 times 100, I have an equation that I can solve for x. So we're going to simplify. We have 90 times x equals 4,000. To get this x by itself, we have to divide by 90. I hope you guys practice some of this division without the calculator, because you're going to need to divide 4,000 by 90. Alright, you could take a shortcut. You can simplify this and just have 400 divided by 9, and that will work. That's just reducing this fraction off right here. 9 goes into 40, 4 times, 9 times 4 is 36. Whoops. 9 goes into 40, 4 times. It doesn't look like this is going to come out even. It looks like what's happening here is a repeating 4. So do we have some rounding instructions? Yes, we do. We have round to the nearest game. That means the nearest ones. So this 4 tells us this rounds to make 44 games. radicals. So we're trying to simplify 2n times the square root of 50 n to the 7 c to the 8. All right, this 2n on the outside is just hanging out, but he's going to multiply times anything, any perfect squares that we do simplify is going to multiply times that 2n. So this is what I call the perfects and the not perfects. So we're going to break up this 50 to be two numbers that multiply to make 50, and one of them is a perfect square. So that would be 25 times 2. All right, when you look at variables and exponents, remember that all the even numbered exponents are perfect, because to take the square root of them, you cut them in half. So when you have an odd number exponent like 7, you have to split it so that you have an even and one extra. So we're going to have n to the 6 and one extra. Well, that's still n to the 7 because 6 and 1 makes 7. We just split it to be an even and one extra. So the c to the 8 is perfect because 8 is even, so we can put it in the perfects. All right. We still have this 2n hanging out here. All right, he's going to multiply times the square root of the perfects here. So the square root of 25 is 5. The square root of n to the 6 is n cubed because we just cut the exponents in half. The square root of c to the 8 is c to the 4. We still have our not perfects. They never really do anything. They're just hanging out. And now we're going to multiply 2n times this. So 2n times this makes 10n to the 4th because we add the exponents when we multiply. C to the 4th times the square root of 2n. Those are the not perfects. They just come down. And there we go. We're done. All right, number 34. Another word problem. A rectangular pool is 9 meters wide and 12 meters long. If you swim diagonally across a pool, how many meters would you be swimming? So I always find it useful to draw pictures when my word problems involve shapes. So I'm drawing a picture of a nice rectangular pool that's 9 meters wide and 12 meters long. I'm going to swim diagonally across the pool. Well, that would be here. Okay, so the key to this question is that you're not really working with a rectangle. When you swim diagonally or you move diagonally across a rectangle, you have split the shape into two right triangles, and you can see the right angle right here. So we're really only dealing with this triangle shape right here, because this is what we're trying to find, and it's not part of the dimensions of the rectangle. It's part of the dimensions of the triangle. It's half of the rectangle. So to find a dimension of a right triangle, we use Pythagorean's theorem. I don't know if I can spell that, but if you remember Pythagorean's theorem, it says a squared plus b squared equals c squared. And these two sides are the legs of the triangle that make the right angle. So that would be the 9 and the 12. So 9 squared plus 12 squared is going to equal the long side, or x squared. 9 squared is 81, 9 times 9. 12 squared, 12 times 12 is 144. When you add 81 plus 144, I'm going to pause, let you guys add it. No calculators. You get 225. So does that mean that the length, the diagonal length here is 225? No, it doesn't. It means that x squared, if I squared it, it would be 225. So to get rid of this square, we use the radical, because that's the opposite of the exponent 2. The square root of x squared is x. Square root of 225 is 15. So the pool is 15 meters diagonally.